Welcome to this video. In this video we will apply lever rule in eutectoid part of the iron carbon diagram. So this diagram we have seen in previous video that we have perlite, ladeubrite, austenite, alpha ferrite and proeutectoid alpha ferrite in this region and proeutectoid cementite in this region. These both are with the composition perlite. So proeutectoid alpha ferrite will be on the boundary region and in the green there will be perlite formation. Here the proeutectoid cementite will be in the boundary region and in the green there will be perlite. So we will find percentage composition of these components with the help of the lever rule. So here we know it is 0.025 percentage carbon if we draw a straight line from this triangular point. At eutectoid point we know that 0.8 percentage carbon is there, and at the end of the iron carbon diagram there is 6.67 percentage carbon. So now we will consider two cases. In first case we will take composition percentage C1 where it is in between these two percentage composition of carbon and it is on the left side of the eutectoid point. The second case we will consider on the right side of the eutectoid point and we will say it C2. So now the tie line we have to draw, it's a simple distance calculation. So this T distance is between C1 and 0.25, U distance is from 0.8 to C1, V distance is from C2 to 0.8 and X distance is 6.67 to C2. The total length of this line will be 6.67 minus 0.025, so we'll get total length. And we can also calculate this length, which is 6.67 minus 0.8, and this length as T plus U as 0.8 minus 0.025. Now I have drawn this line for C1 case and C2 case separately. So T and U, this particular line I have drawn it here, and there is C1 composition in between. This line is V and X. So this is the line where 0.8 is on the left side and 6.67 is on the right side. So I have drawn these two lines for easy visualization. And C1 and C2 are percentage of carbon randomly. Anyone can ask at this particular point also and or at this particular point also, we don't know. So C2 is a random point between these 2 points, C1 is a random point between these 2 points. Now first case is we have to find the percentage of proeutectoid ferrite. So proeutectoid ferrite means we have to consider this part only, the T plus U line. So here only the proeutectoid ferrite is present. So proeutectoid ferrite, which is alpha ferrite, is before eutectoid point, so before this point, so we have to consider this tie line. Now simply it is U upon T plus U. So how it comes is, the more C1 closer to the alpha line, alpha ferrite line, more will be the alpha ferrite, right? So the U length will be bigger. The bigger the length, if this point is closer to 0.025, then U length will be bigger. So U will be bigger means alpha ferrite will be more. Hence it is closer to the alpha ferrite. The more closer it is, the proeutectoid alpha ferrite will be more. So that's why we have to consider U. And percentage fraction of perlite in case 1 here, what percentage of perlite is present in this region. So we have to simply calculate T upon T plus U, T upon T plus U total length. So U divided by total length will give you proeutectoid alpha ferrite, T divided by T plus U, T divided by total length will give you our percentage fraction of perlite in case 1. We have to calculate U. So U distance is 0.8 minus C1. C1 can be given in question, upon total length is 0.8 minus 0.025. Similarly we can calculate this distance is T as C1 minus 0.025. T is C1 minus 0.025 and divided by total length, which is 0.8 minus 0.025. Now similarly we have to calculate for this line. if we asked proeutectoid cementite, so proeutectoid cementite we have to consider this region, because here proeutectoid ferrite is present, here proeutectoid cementite is present. So proeutectoid cementite is on this side of the line, right, and perlite is on left side of this line in the composition. So after 6.67 percentage carbon there will be pure cementite. So to calculate cementite we have to calculate opposite distance. So v is opposite distance, so more the C1 C2 point is near to this cementite line, the v length will be bigger. So bigger the length, cementite will be more, and it is closer to this line. So that's why we have to consider v. So v upon v plus x, v plus x means total length 6.67 minus 0.8. So it is v is C2 minus 0.8. Similarly, percentage fraction of perlite. Perlite is on this side of the line with cementite. On this side it is pure cementite. On this side of this line, this 6.67 line, it is mixture of perlite plus proeutectoid cementite. So perlite composition, the more the x, the more will be the perlite, because it is, if more the x, C2 will be closer to this eutectoid line, so more will be the perlite. So percentage fraction of perlite will be x upon v plus x. So x is 6.67 minus C2 divided by total length. Now this in blue color is Eutectoid alpha plus Eutectoid Fe3C, means both these will form as a perlite in this region. Here Eutectoid alpha plus Eutectoid ferrite, we are talking about this side of the line in case 2. Now on left side, means Eutectoid point left side is less than 0.8 percentage carbon is this region. Here if we have to calculate total alpha, then we have to calculate proeutectoid alpha plus the alpha present in the perlite form. Similarly, if you want to calculate cementite in this region, we have to calculate proeutectoid cementite plus the cementite present in the perlite formation. So we have to add these two, but we can directly calculate from the total line. Now let's consider first percentage alpha ferrite total. So total is, we have to consider total line 6.67 to 0.025 tie line. Here the C1 case we have to calculate in C1 case. So in C1 case we have to calculate proeutectoid alpha plus alpha in perlite form, which will be mass of total alpha. For case 1 means C1, for case 1 we have to consider 6.67 minus C1, this length, because C1 is closer to alpha, so bigger the length, more will be the alpha. C1 is closer to alpha, so bigger the length, it will give more alpha. So this length we have to consider u plus v plus x, which is 6.67 minus C1 divided by the total length, which is 6.67 minus 0.025. This will give the total alpha present inside the microstructure at C1 point. Now in case 2 we have to consider v plus x, which is 6.67 minus C2. So C1 and C2 are random points, we can again consider either one. So it is similarly divided by total length. Now in the same manner we can also calculate total cementite percentage Fe3C total. So in total we have to consider the tie line for total 6.67 to 0.025. Now for C1 point we have to consider, we are calculating Fe3C. So here it will be proeutectoid Fe3C plus it is present in the perlite. So total mass will be given as C1 minus 0.025, means this T length, because cementite is present on this side. So if C1 is far away, we have to consider the shorter length because cementite will be less. So C1 minus 0.025, exactly opposite of this alpha. 6.67 minus C1 will give you the alpha ferrite, and C1 minus 0.25 will give you the cementite, total cementite. So we can apply lever rule in parts or in total. So in total it will give you total amount of alpha and Fe3C. Here for the case 2, C2 is considered, so T plus U plus V divided by the total length will give you the cementite present in at C2 composition, the total cementite present in C2 composition. So this is the video for calculating microstructure percentages with the lever rule. If you like this video, please subscribe the channel, because I'll be uploading similar kind of videos for all the subjects hopefully. And do share this video if someone is preparing for competitive examination. Thank you for watching this video. See you in the next video.